This is Tim Bryce with my column entitled Process Templates. When we developed our automated systems engineering tool, it forced us to fine-tune our concepts for system design. It was based on our concept of information-driven design, meaning it could deduce a complete system design based on the information requirements of the user. If the requirements were incorrect, the design was incorrect. However, in the hands of someone who understood requirements definition, it could save them considerable time in either designing a new system or documenting an existing one. Based on requirements, our ACE product decomposes a system into its subsystems, its business processes, if you will, the procedural workflow for each, and determine what programs are necessary to implement the computer procedures, software specs. To do this, we determined there were three basic types of subsystems: file maintenance, also known as data collection; information retrieval, queries in the form of reports and screens; and a combination of both maintenance and retrieval. This implies there are primarily two functions we can apply to files: read for our queries, or write, meaning update. One of the key design parameters was the timing of the information requirements. For example, the need for specific information on a daily basis, weekly, monthly, quarterly, etc., or upon request, also known as on demand. To decompose subsystems into procedural workflows, it is necessary to understand other properties. For example, all processing involves the use of transactions, either one at a time, such as to make a query, or volumes of transactions, such as batch processing. The workflow of a system involves the use of the processing constructs of sequence, iteration, meaning repetition, and choice, meaning branching. Further, the workflow has one or more starts and continues uninterrupted until it reaches end. Between the timing of the subsystem and transaction volume, we can make some assumptions in terms of procedural flow. For example, a subsystem needed upon request with a short response time, such as in seconds, would inevitably result in an interactive subsystem. Conversely, a daily or weekly process involving several transactions implies a batch process. From these specifications, we can deduce standard business processes using templates. For example, template number 1 is batch file maintenance, where you would start, and procedure 1 would be input preparation. Procedure 2 would be data conversion, be it data entry, optical recognition, or some other form. Process 3 would be update files, computer processing, and procedure 4, review, to verify transactions were entered correctly using a log and implement necessary corrections. And then finally, end. This is typically a sequential process. Template 2 is interactive file maintenance, where you start and you have process 1, where you input transactions one at a time through a screen. After reviewing data validation, either print, correct transactions, enter another transaction, or end. And process 2 is update files, computer processing, producing data validation screen. And then you go to end. This is typically an iterative process. Template 3 is interactive query, where you start and you have procedure 1, input transaction representing a request one at a time through the screen. After receiving information, either print, make another request, or end. And process 2, read files, computer processing to produce information on screen until you come to an end. This too is typically an iterative process. Template 4 is a batch request, where you start, you have process 1, where you have input transaction representing a request either manually or scheduled. Process 2, read the files, computer processing to produce reports. And procedure 3, review and distribute reports, and then end. This is typically used for such things as weekly, monthly payroll, weekly, monthly, quarterly, annual reports. And finally, template 5, interactive read-write selection, where you start and in procedure 1 you select action and input the transaction through screen. If updating files, review the data validation, either print, correct transaction, enter another transaction, or return to screen. If querying information, either print, make another request, return to menu to select another action, or end. Procedure 2 would be read-write files, computer processing to either update files or produce information on screen. And then you come to an end. This is typically an iterative process. When designing subsystems, an application logical database is created to service the data needs for all subsystems, not just one. Then as the subsystems are designed into procedural flows, the application physical files can also be deduced, including working and primary files. Also, inputs and outputs are deduced and attached to the various processes. These 5 templates represent the bulk of processing in companies. There may be other types of subsystems to manage the overall system or to handle files, such as file initialization, backup, security, migration, meaning import-export. But these 5 templates can be used by any business. Of course, such templates are modifiable to suit the nuances of a business simply by adding or removing procedures. Pictorially, we flowchart the subsystems and procedures using standard ASCII flowcharting symbols, which depict both the processing flow and data flow. Let's talk a little more about information-driven design. This is all made possible by defining our terminology and concepts. Information-driven design concentrates on the proper definition of information requirements. Timing will ultimately dictate how data will be collected and stored, specifying your availability requirements, and how data will be accessed to produce information. From this, we can deduce both processing and data requirements, thereby providing for design correctness. When decomposing the system into subsystems, the emphasis is the design backwards, from information requirements back to data requirements, from the receiver of the information to the originator of data, from outputs to inputs. Later, as the subsystems are decomposed into procedures, the process is reversed. Here, the design process expresses how data will physically be processed in order to produce information, going from source of data to the destination of information, from inputs to outputs, from start to end. This is also true in determining the programming of computer procedures from start to end. The required data must be defined in such a way that we can easily understand what primary data must be supplied by a user and what generated data must be calculated internal to the system. Data relationships can be extensive. For example, take net pay, as in your paycheck, which may be based on a complicated computation, such as net pay equals gross pay minus FICA minus city tax minus union dues minus whatever else. The data elements used in the formula may also be calculated, such as gross pay equals hours worked times pay rate. This means in order to arrive at the correct value for net pay, we must be able to reach all of the primary values, such as hours worked and pay rate, in a timely manner. If we cannot do this, net pay will be incorrect. Information-driven design and the use of standard processing templates greatly simplifies the design of systems, thereby saving time on the critical upfront work that is normally overlooked. The result is a viable design of both the processes and the data. This approach is universally applicable and based on tried and proven approaches fundamental to sound system design. The hitch, though, remains defining the information requirements properly. If they are correct, the design will be correct. However, if they are incorrect, no amount of elegant programming will correct a flawed design. Friends, keep the faith. This is Tim Bryce in Palm Harbor, Florida. Follow me on the internet at timbryce.com.